Let's work on this problem. This is the problem with the combination of two or three homework problems. So if you understand how we get Fourier series coefficient from this problem, you should be able to do homework problems. So you are given in this signal now as an x of t, and we can put this into equation, and x of t equals, it's gonna be 2t. We're talking about this portion. That's the 2t. How do I know? It's rise over run. It's just a linear equation. When t is in between 0 and 1, and then it's going to be 2 when we have t is from 1 to 2, and negative 2 when we have the t is 2 to 3, and all otherwise it's going to be 0. And now we have Fourier coefficient equation C of k equals 1 over t naught integral over the fundamental period t naught. We have x of t times e to the negative jk omega naught t dt. So now we need to find out t naught. T naught is period of the one signal that is going from, let's say we start from here, and then all up to this, and then we need to include this portion as well. So that's the starting point at 4 and starting point at 0 now is repeating. Therefore we have t naught equals to 4. That means omega naught equals 2 pi over t naught, which is 2 pi over 4. That is pi over 2. Now we need to put this x of t into this. So we have c of k equals 1 over 4. The first term going from 0 to 1, x of t to t e to the negative jk omega naught. Omega naught is pi over 2, plus the second one is 1 over 4. We're going from 1 to 2, and we have a 2 times e to the negative jk pi over 2 t dt, and then plus 1 over 4 going from 2 to 3. This time we have a negative 2 as an x of t, and e to the negative jk pi over 2 t dt. The first term, we need to do the integration by part. So I'm going to let u equals to t, and then dv equals e to the negative jk pi over 2 t. V equals negative 1 over jk pi over 2 e to the negative jk pi over 2 t. Should have dt right there. And then du equals to dt. Now we just multiply this and this. Then equals, I'm going to take 2 in front of the integral, so we have 1 over 2, and then uvt times negative 1 over jk pi over 2 e to the negative jk pi over 2 t, going from where? 0 to 1, minus integral 0 to 1 v du negative 1 over jk pi over 2 e to the negative jk pi over 2 t dt, plus we can take out 2 to the front, then we have 1 over 2 times negative 1 over jk pi over 2 e to the negative jk pi over 2 t, going from where? 1 to 2. Now we have one more. We can take negative 2 to the front, negative 1 over 2. We have negative 1 over jk pi over 2 e to the negative jk pi over 2t. This time we're going from 2 to 3. Now that equals, we have a 1 over 2 in the front, and we're going to plug 1. Then we have a 1 over jk pi over 2 e to the negative jk pi over 2. minus, when you plug it 0, e to the negative jk pi over 2 times 0 will give us 1. However, we have a t in front of it, so it's going to be 0 minus, we have negative 1 over jk pi over 2 times negative 1 over jk pi over 2 e to the negative jk pi over 2 t going from 0 to 1, then minus 1 over 2, 1 over jk pi over 2, and e to the negative jk pi over 2 times 2 minus e to the negative jk pi over 2 times 1, and minus 1 over 2, actually, so plus and minus minus plus, we have 1 over jk pi over 2, and then when you plug 3 in, e to the negative jk pi over 2 times 3 minus e to the negative jk pi over 2 times 2. That equals 1 over 2. I'm going to take negative 1 out, so negative 1 over 2. We have a 1 over jk pi over 2 and times e to the jk pi over 2 minus, we have 1 over jk pi over 2 square and e to the negative jk pi over 2 minus 1, and negative 1 over 2, 1 over jk pi over 2, we have e to the negative jk pi minus e to the negative jk pi over 2, and plus 1 over 2, 1 over jk pi over 2, e to the negative jk 3 pi over 2 minus e to the negative jk pi. Okay, so now let's simplify a little bit. So we have this 1 over jk pi over 2 square. So we can factor out. We should have big bracket in here, taking all 1 over 2. So if you factor out negative 1 over 2, 1 over jk pi over 2 square, then the first term, we didn't have the squared term, but we're going to factor out squares, so we need to have jk pi over 2 e to the negative jk pi over 2, and minus e to the negative jk pi over 2 plus 1. And we want to factor out 1 over 2 times 1 over jk pi over 2. We have a negative 1 over 2, 1 over jk pi over 2 out. Then we have e negative jk pi minus e to the negative jk pi over 2. Since we take out the negative, we have a negative e to the negative jk 3 pi over 2 plus e to the negative jk pi. When we look at this square term, if you square them, we have a 1 over j squared k squared pi over 2 square, and then j squared equals negative 1. Therefore, we have 1 over 2, negative 1 times negative 1 over 2. This will give us positive 1 over 2. And then the rest is 1 over k pi over 2. So still square. Put it back square there. And then if we take out e to the negative jk pi over 2 out, then we have a jk pi over 2 minus 1 and then plus 1 outside. Second term, if we look at this e to the negative jk 3 pi over 2 is actually the same as e to the jk pi over 2, because negative 3 pi over 2 is actually the same as pi over 2, right? So pi over 2 is here, and then this is negative 3 pi over 2. Therefore, we can rewrite those terms as 1 over jk pi over 2 e to the negative jk pi, and then I'm going to have the same term plus e to the negative jk pi. Then we have minus, if we factor out, e positive jk pi over 2 plus e to the j negative jk pi over 2. And the similar way, pi equals to negative pi. So if we rewrite this 1 over 2, 1 over k, 1 over 2 times 2 over k pi, I'm going to take the denominator, the 2, to the numerator, and we have e to the negative jk pi over 2, jk pi over 2 minus 1 plus 1, minus 1 minus 1 over jk pi over 2, and we're going to bring this 2 to inside. Then we have e to the jk pi plus e to the negative jk pi over 2 minus e to the jk pi over 2 plus e to the negative jk pi over 2 over 2. I changed from negative jk pi to positive jk pi because pi equals to negative pi. Then 1 over k pi times e to the negative jk pi over 2 jk pi over 2 minus 1 plus 1. And then we're going to move this denominator, the j, to the numerator. Then we have plus j2 over k pi. And the first one is the cosine k pi. Second one is cosine k pi over 2.